Okay, so yes, all right, it works. All right, the one part I always hate doing is the chemistry notes because they're god awful. Um, because you have to draw stuff and you have to do this shenanigans, which is a pain in the ass. But yeah, generally speaking, you don't really want to use any off-batted. So if you're gonna study chemistry, basically what you're gonna be given is a periodic table. That's all. This is all. This you're not gonna give any of the other periodic table. But the general idea is that if you have the periodic table, you can use it to generalize what you would expect. It might not be true, but you can generalize what's going to expect when these two interact with each other. You're gonna get a B positive, and you're gonna get an F minus, and that's gonna turn into some kind of ion, no compound. Which because fluoride is I refuse to deal. I think it's gonna be I can't say that word. Whatever, but that's a general idea. So when I put this thing up here, which thinking about it, I could just do this copy and put it in here, making it easier. Hopefully that did work. Yeah. So in general over here, if you look at these few over here, I put that there could be more because there is more. I believe FV has four as example I put, but it has like five and one too, I believe. It's the most common one in every single test they show up. But copper over here also has what happened there? Also has many different versions. I think there's three, four. Um, I think this is either platinum or gold. I don't remember. PD is platinum, I believe, and gold is what's again? I think it's AU next to it. It's like a dash. Yeah, AU, and this is platinum over here. This is silver. I remember these four metals because they are, valuable. All right, this over here is nickel, cobalt. I don't know what that is. Oh no, that's lead. That's lead. Is that gallium? I think it's gallium. It has to be gallium. Now, we all know carbon and boron because they're obvious. This is nitrogen. Nitrogen. I think that's nitrogen. That's oxygen, fluoride, as I said, hydrogen, chloride, bromine. I don't know. So that's the first one I don't know. I don't know this one either. But you don't need to memorize any of these because you're going to have to do them anyways. And they're most likely going to be ingrained in your heart after you take 6A. I don't know. Actually, at least these ones, hydrogen, lithium, benzoylene. Can't really say that correctly. Sodium, magnesium, potassium, and calcium. Everything else here is a blur. I don't really know much of it. But as you can see, you will be naturally be able to figure this out after a few times you looked at this PI table after a while. Uh, yeah. Actually, another important one is lead because professors love to give that one for some reason. Uh, where is it? And then another important one is uh, all of the noble gases because of the electron configuration that the professor loves to give. I believe argon and they don't really like krypton. They like Leon for some reason and radon just to give that those. I don't know why they like to give those, but my test they kept on giving those three for electron configuration for some reason. I have no idea why the professors like that. I don't know. Um, Probably because I don't know. I really don't know. But yeah, those are the once again the elements in the periodic table that professors love to toss at you. But some of them make sense, some of them doesn't. I still don't understand why the professor put a radon question. Like he was given the electrical configuration of I forgot what is this again? Radium, and then you have to do it the whole way, and then with the radion for some reason. electric configuration. I don't know why the professor liked that question. Well, he gave those questions up for no. I mean, there was no good reason for it. You can just simply give a neon question and it'll be the same thing with electrical configuration. Anyway, yeah, that's a general idea. So I did write here that there's more variation, and it's just to go best to go with your best judgment. Your judgment is king here, I think, because the PR table is complete. Just you know, they give you this. They don't have anything here. They don't give you the what this means or anything. You have to just figure it out. So I can just say that the peer table is more like a guide for your intuition. So another example of that is over here with the ionizing energy, the affinity and electronegativity, radius of the atom. There are certain elements that break this trend. For example, these over here, because of how they interact with electronegativity, these over here, not the noble gas, but this over here breaks some of these rules. But in general, if it's like going this way, you can figure out like what's gonna happen with the element. That's the main purpose of it. I forgot what happens here, but I'm pretty sure what happens is that there's a big atom over here, like this, and it suddenly dips off because what happened is that they trying to get perfect to this thing, and then this is so much. I forgot. It's like how far off from the uh, noble gas. They call it noble gas because they're a stingy bitch that doesn't like to bond with anything. That's basically what their purpose is. Um, but yeah, that's the PR table.